If I were to ask you, where is an electron in the atom? You would not be able to tell me. And I can't tell you either. But what I can tell you is a way that we can talk about where it could be. And that's a key difference. When we talk about the address of an electron, we generally talk about its electron configuration, which talks about where it could be in specific energy levels, in specific sublevels of that energy level, and then in specific orbitals of that energy level with spins up or spins down. Now, the driving idea behind this is Werner Heisenberg's uncertainty principle, which says that we cannot know both the location and the momentum of an electron at the same time. We just can't, because the very act of observing where an electron is disrupts its behavior at that moment. So what we do is settle for less. We say that, okay, if I don't know where the electron is exactly, then I can at least talk about where it could be in a region of space of probability that's called an orbital. Think of it like this. If I came up to you, me a complete stranger, you a complete stranger, and I told you that I live in Georgia. You do not know where I live in Georgia, but you do know that I live in Georgia, at least somewhere in Georgia. It's that same way that we talk about orbitals, right? The s orbital, or sorry, they're sublevels technically. The s sublevel has one orbital. It's spherical. So I can't tell you where the electron is exactly in that sphere, but I can tell you it's in that sphere. It's somewhere in that sphere at any given moment. So it's that same idea. We can't tell you where exactly the electron is, because the more we know about where an electron is, the less we know about its behavior. Conversely, the more we know about an electron's behavior, the less we know of its position, which is Werner Heisenberg's uncertainty principle. So again, an electron configuration tells us where certain electrons of an atom or element could be. Not where it is, but a region of space of probability that tells us that at any given point, it could be in this space. And this is important because then it tells us more about the core electrons of which energy levels electrons occupy in each element, of the valence electrons, which play a critical role in bonding, and much, much more.